Yeah. I hope you are able to see my screen, right, everybody?
Yeah.
Thanks. So, my name is Nageshwar. Currently, I am working as a project lead at Value Labs. I have overall 10 years of experience. I started my career in 2016. After MTech from NIT Trichy, I got into Mercedes-Benz R&D Center, Bangalore, through campus placements. There, I worked almost like 4 5 years, close to 5 years. Uh, in the starting, I started with a little bit of Python automation, I would say, around 2017, and then I got chance to work on the object detection, computer vision use case, basically object detection, object classification, building customized CNNs and ANNs. So majorly in the starting, it was all about deep learning work. Majority of the companies were into that, and then from past 6 to 7 years, I am into NLP, natural language processing. I have worked on text summarization, classification, entity extraction, these kind of use cases using pure NLP. And from 2022, I am into generative AI and AI agent space. In this multiple RAG use cases, 2 3 RAG use cases I have worked on, and multi-agent orchestration and the spec-driven development. Recent one, where our agentic system will take the technical requirements, unstructured technical requirements in the form of PDFs or meeting notes of any product owner or calls with the client, these kind of things it considers, and then writes the code, QA, does the QA review, and push it to GitHub branch, feature branch, one of the GitHub feature branch. So that is the latest one. So this is a brief introduction about me, and I will be taking this course starting from Python. We start with that, and then introduction to machine learning and deep learning, generative AI and AI agents. So I'll be teaching this course. I want to hear a little bit from you also, like what is your expectation, and if you are comfortable, maybe you can give brief background. Yeah, please go ahead. Anybody?
Yeah. Hi, Nagesh, sir. Good morning. I'm
Hi.
myself, Loka. Yeah, actually, I'm having 11 years of experience in IT industry. Currently, I'm working as a data engineer, like with
Okay.
the Azure Databricks and the ADF, all those things. And currently in the
Okay.
market, mostly we are getting like the calls based on the AI engineer or the agentic engineer, all those things, and we need to use all the cloud models, all those things, right? I want to just get into that like a bit easily. This way, I'm looking for this course. Yeah,
Got
and
it.
along with that, mostly going forward, all the what are the projects and all are going to come? Those with AI only, mostly at least 30%.
Mm.
Yeah, that's why I want to go with this course. Yeah.
Thanks for starting. So next, anybody?
Hi, Jyotirnath here.
Hi, Jyoti. Good morning.
Good morning. I currently have 12 years of experience working with a product company. Currently working as data architect plus senior data engineer roles, kind of roles. I would
Okay.
like to understand what is the, outcome of this course. Like, what we are trying to achieve.
Mhm. Okay, you want to know the curriculum, what will be covered?
Yeah, what will be covered and what roles we could target after completing this.
Okay. Yeah, I'll try to cover as much as possible on that part. We have a slide for that. Let's see. You are already working as architect, right?
Yeah, I did, and also have knowledge on Gen AI. I build tracks as well. in my current company.
Uh, okay,
I
great.
just want to know the relevancy, like how relevant is this to me?
Hmm. If you know till rag, then agents you should target for AI agents and multi-agent orchestration, these things. Apart from that, yeah, then you'll be able to handle complete this AI projects, anything.
Got it.
If you, yeah,
I'm good.
yeah. Anybody else, please?
Hey, hi, Nageshwar. My name is Narad Shaku. So,
Hi, Naraj.
yeah, my expectation is to grow my career towards AI engineer. Currently, I'm working as a QA lead. I have 8 years experience on automation testing.
Okay,
My,
okay.
my goal is to combine my QA automation experience with AI and
Hmm.
eventually become as a AI engineer.
Got it. So
Yeah,
you might be using already like to write the test cases, and already you might be using AI, right?
yeah. AI. I'm using different AI tools to develop the automation scenarios.
Okay.
Um, but I want to become a AI tester, so I want to be test RAG and
Mm.
LLMs. How to we judge on AIs.
Yeah, I feel it is like this one testing in AI. It has a lot of scope. I feel because
Yeah.
nowadays what we are doing, developers are doing the testing majority, like very because normal testing team which is there
Yes.
for
Yes.
they are not familiar with it. Yes, it definitely it will have a lot of scope. But the thing is, we need to understand AI systems as well, bit
Right.
at least.
Yeah, that's
So,
why I joined this course. So basically, so we need to understand the root of the AI.
mhm.
So then we know how to we test the AIs, agents or any agent tool.
Okay, got
Yeah.
it. Yeah, we will cover that this evaluation frameworks actually.
Right.
Ragas, DPeval, multiple are there. We will cover those frameworks.
Okay.
Yeah,
Yeah. That's all from me.
yeah. Thanks, Navrat.
Yeah. Thank you.
Anybody else before we start? Okay. So here are the few things. Please be interactive. Ask as much as possible. I don't restrict. I don't mind even if you ask me how much ever like simpler question it may be. I'm not here to judge or anything. Please be feel free to ask questions. Um, yeah, that is the first thing. And second one is we will be sharing some assignments as part of this course whenever we finish one particular topic. And please try to complete that. That is the second one. So if you follow these two, I am sure you will be able to learn. Your time will be utilized effectively, whatever the time that you spent on this course. So let me share my screen now back again and just to showcase or introduce you to the domain. I have planned a few use cases and then we will move on to the presentation part. Yeah, without much theory, let me share. So this is from Google actually, a kind of type project that they have built. You can build something. Let me start it. Here you can see we have two, I would say boxes. One is class 1 and class 2. You can change the name here. Let's say 1. And here I am giving name more. And I am starting my webcam. You can see me now. So this is, I am just creating a record and it should be clear.
Yeah, yeah.
Yeah. So I'm creating some data set here, image data set with my fingers, which look like, let me create few more, around maybe 50. And maybe don't consider this as something. Actually, I mean to suggest different variations of showing one. That is what I am trying to do. Yeah, that is enough. Now, let me create for more. Now, I am just starting with two, maybe these three. Oh, sorry, this is gone. This should be one, right? Yeah, this is three. And now with the other, two more. Okay, around 50 it should be enough. Yeah. Now, what I have done here is I have created image data set basically with my own uh, fingers, which shows in one data set we have one what to say, showing one symbol, and in the other data set we have showing multiple. So this is two different classes that we say in technical terminology. So now what I am going to do is I am going to train the model using this. First one is, first classification or first group of images that I have is showing one, and second group is showing multiple. So let me train this model. So it's training. It would take some time, obviously. So now I'm not showing anything. You can see when I show 5, it is showing it as more. And let me show 1. So it is with 96, 97% confidence it is showing a 1. And let me show 2. See, this is, and it is working perfectly, our model, because it is very simple data set that I am trying it out on, or the simple use case. So yeah, so here, what did we do? Let me reload this so that my camera will go off. So what did we do here is I gave some data to a model, something it is. It can be anything, right here. Yeah. So what I am doing here is this image data set, that is class 1, and another data set, class more. So I had created some 50 plus images of this one, and some 50 plus images of this one. And sent to a model and trained it, training on this data set. Then when I ask for prediction, it is able to do prediction. So this is what it is. Machine learning is all about this domain. At least till deep learning, it used to be the case. So what we have done, we have some data with us. We have some data with us. Along with that, even I gave input that this images contains ones, this images contains more than one. That is labels. These labels also I gave in it as input. So data plus labels are output basically. I can say what that model should predict. Data plus output that I gave. Then model has learned something from it. Model learned. I can say that pattern or rules or anything, whatever it may be, something model has learned, and now it is able to make prediction. So you give me image along with the labels, I will train a model, and that model will be able to predict for any other new image that you come up with, because it has learned how does the one look like, how does the more look like. That is what is machine learning. Here, in case if I have to do it through traditional ML, let us say, I will take one simplistic example. I have 9 by 9 pixel image. Let us say I have one letter written here. So this is how it looks like. I am just filling that black color. So this is one. So for this, let's say I want to write a program that can identify whether there is a one present in the image or not. How I would have done it? If pixel intensity, we represent this with this black color. So this is having 0 intensity, and this is having 265 value maximum. Don't worry too much about like how do we represent and all. Usually, if there is a full black color present, then we say that pixel intensity is 0. If it is full white, then the maximum pixel intensity is 255. So that is 255 pixel intensity. So what I would have done is, so I would have considered this is the position 0 in 0th row. This is row, 0th row, first row, second row, and 0th column, first column, second column. So if this is 0, 1, intensity of 0, comma 1 is equal to this is what 0, right? And intensity of pixel, this one, first row and first column is equal to 0, and intensity of second row, first column is equal to 0. Then you could have classified it. Let's say just I am printing. Print contains 1. So now I would be able to do that. And what if it is different shape? So then I need to come up with these kind of different rules. But is it possible to come up with this kind of conditions or rules as a human being to identify any object? This is not practical, right? I cannot come. Let's say I want to write this kind of program that can identify the dog, that can identify the cat, elephant. How do I come up with that kind of rules? It is not practically feasible. So that is where traditional machine learning is what to say excels at. That is, in case of traditional software building, application building, uh, what happens is you have built your program. That is, you write your rules, you write your whatever the basically you create your own rules and give the data to that. Then it will predict. Predict output, or I would say as of now here, let's say I want to predict the label that it is one or two or elephant or cat, whatever. That is the label, we call it. So that is what we need to do. As a developer, you need to write these rules. But in machine learning, it is reverse. You give the data, sample data, along with the data's labels. You give the labels to machine learning model, ML model. Then it will learn the patterns automatically. Learns patterns or rules automatically and predict it for any image. So that is the difference. So what is ML? I can say that without explicitly writing rules, writing or creating rules, we will be able to train model, because model itself will learn it. That is what it is. So this is the one part of it. So if I have to define machine learning in simple terminology, it would be teaching the machine to learn the patterns inside the data so that it can make the predictions on any unseen data. That is what it is. So this is about machine learning. And then let us go back to any questions on this, whatever we have discussed till now. So there is no explicit what to say. We will not be writing the rules. We just give the model data and labels. Then it will be able to learn the patterns and rules and predict the output. That is what it is. Here also same thing we had done. We had given the data, that is images, along with the labels, and we have trained it, and then it will be able to predict it. That is what it is. And those rules and all, we are not writing them explicitly. How does the one look like, or anything look like? Model itself is learning that those patterns. It is learning. That is machine learning is. Now one more use case. This is it is applicable for any, actually, not only machine learning, even like for deep learning till generative AI part. This used to be the case. You have the data with you. You just throw that data along with the labels to the model, and it will learn the patterns and come up with the prediction. That is used to be the case. So that we used to call it as predictive AI. That is, your ultimate objective here in these cases was predict something. It could be predict label like we saw, or predict some numerical value. So these are all comes under predictive AI. Again, traditional ML and deep learning. These two, whatever we used to do, they are predictive AI. And now, what is generative AI? Generative AI is fundamentally different from predictive AI, not in terms of working or internal. How do we train it? Nothing difference actually. Only difference is what is the purpose? What is the goal? Ultimate goal here of the model building or model training. That is the only difference. So there in predictive AI, the ultimate goal or the objective for the model training used to be prediction, one single prediction that you want as output. But in generative AI, the objective of model training or whatever the application is to generate the data, to generate the data. new data, I would say, based on the patterns model has seen during training. So here also it sees some patterns and comes up with a prediction. And here also it sees some patterns and generates the new data. That new data can be text data that you see in case of LLMs. It can be video, it can be audio, it can be images also, right? And how does it generate this data, new content? It all based on the pattern that it has seen. It has seen that after I, majority of the times am comes, so it generates am. After after this combination of words, I and am, majority of the times it has seen going, so it generates going. That is what it is. Pattern is nothing but. So it has learned all these patterns and coming up with when you what to say initialize that seed that you give or the input that you give, that is the prompt, then it comes up with this. That is what it is. So we'll I don't want to get into too much on that. We'll stop there. So this is the difference between predictive AI and generative AI. But ultimately, what is like looking at these two definitions? What is predictive AI? You predict some label, you predict some numerical value depending upon the problem statement. So this we call it as actually classification. That is your ultimate your objective here is to predict a label, and this we call it as regression. That is here you want to predict some numerical value. We'll talk about those also later on. If you don't understand, don't worry too much. But here, in general, what is AI? Looking at these two definitions of different categories of AI. So here I am trying to teach the machine to learn something or to predict something. And the same thing here, it is completely generating new content. So I can say that I am trying to build AI is about building intelligent machines. That's all. That intelligence, how much intelligent they are, like human level intelligence or above human level, it is up to like now we have different definitions for that also, like AGI, they say, and ASI. AGI is artificial general intelligence, right? And artificial super intelligence. So it is this one I can say that they are talking about above human level intelligence. It is like if a model that we are building, if it can perform any generic task that human can do, then that is artificial general intelligence. That is what it means. So anyways, we are not at there. When this ChatGPT was released, everybody was talking about this one only, AGI. We are closer to AGI, general intelligence. Means we have built a model that can do all the generic tasks that are expected from a model. That is like you can see, it can do the math, it can do the coding, it can do the what to say, summarization, text generation, image generation, So that multimodality, we call it as, like, it can generate the content of different modalities, like text, audio, images. So that is what was done, but you know the limitations. It is not up to the mark till not, we are not there yet anyways. So this is AI is for building intelligent systems. That is AI. Now, what is ML? ML is subset of AI, or I can say a part of AI systems, where we train the model and the data and make the model to learn the patterns or the rules that are present inside the data. And that model usage, or the ultimate goal of that ML model, could be like whether you are using it for classification or regression, it can be any purpose. So we are not, without explicitly writing the rules, we are asking the model to learn from the data. So that is ML, is machine learning is. That is why the name machine learning. So machine learns the patterns inside the data, rules inside the data, so that it can predict for any unseen data. So it is able to generally, what to say, it is able to find that generic rules, generic patterns that are observed in the data. So that means that, let us say, it is best explained with images only again. Uh, let's say I'm talking about two data sets which contains let's say um, human, and then which talks about, let's say, at least closer to, anyway, elephant. Okay, now I don't have to tell, or I don't need to explicitly mention that humans will have two legs, and then I don't have to mention or talk about how many hands they have, or what are the features of human. Basically, it is better to write features. But ultimately, what this machine learning model that we train, it can do is, it can identify those kind of features automatically. We don't have to write them, or we don't have to program them explicitly or manually. You don't need to write them. Model can differentiate, okay, human has two and elephant has four legs. These kind of features, this model itself will identify or learn. That is what it is. So what is machine learning? You, in machine learning, you train the model to learn the patterns or the rules present in the data, so that it can make the predictions for given use case. Basically, without explicitly writing the rules, you are training it. That is machine learning. And now comes the deep learning. Deep learning is another subset of artificial intelligence. Here also you will train the models, but here we use something called as neural networks, or its different variations, to train the model. So that is the only difference. We'll talk about what are these neural network and all later on. That is the only difference. And then comes generative AI. Generative AI, we have already discussed on the top. What is generative AI? Here, our ultimate goal is to the training of ultimate goal of training the model is to generate the new content. So that is what it is. Any questions till now? Otherwise, I'll go on. If you don't stop, please ask questions. I would highly encourage, be interactive. Then only I will feel interested. Anything that you are stuck, you don't understand, feel free to ask again. Yeah.
How
So
will we know the model? You were saying ML is learned, that is the human and elephant.
mhm.
That ML is learn. What is the difference between the human and elephant? What logics we are applying here? Like just only we are applying images or any other rules we are applying here?
We don't give any rules actually. We have
Hmm.
some algorithms. Let me go back here.
Okay.
Yeah, uh, using which it will be able to learn. One more main difference between machine learning and deep learning is here we use algorithms to train
Okay.
the model. Here we use these architectures to train the model. We
Okay.
don't write the narrative. We don't write the rules. That is what I.
Okay. Okay. Just I want to know how it is differentiate.
Yeah, okay, okay. Don't differentiate by looking at the data. They have to learn the patterns.
Uh,
I will take one example. I know it is already 42, but let me go back. So let me ask you this question. We have two columns, let's say x1 and x2, and this is the y column. This is the output. Okay. Now I am writing something like this: 1, 2, and this is 5, and 3, 4. This is 11. Let's say this is 4, and this is 6, 60. And then let me say this is 1 and this is 4. And what would be the y? Now, if I ask, what would be your response? Anybody? X1
9.
is 1.
9
Sorry,
it is.
9, right? How did you identify that it is 9?
4 plus 4, 8 plus 1.
It
Yeah,
is
x1 plus x2
x2,
into x2.
right?
Yeah. Yeah.
So this is what it is. Like, this is the pattern. That is, you need to take x1 and multiply x2 by 2 and add them together. That is the pattern that you have identified as a human. And how did you identify that? It is very abstract actually. We have that abstract capabilities to think, abstract way of thinking. But how does a machine can do that? To come up, this is a pattern, right? That we want the model to learn ultimately. Without writing this equation, I want model to predict this output. How can we make that? How can we make the model to learn this pattern? How can we make model to learn this pattern? Yeah, x1 plus 2 x2. This is the pattern present inside this data. And how do we train the model to learn this pattern? It is simple. Like, first thing is I need to assume some what to say, generic equation for that, right? Something like ax1 plus bx2, and then programmatically, now how do I do that? Is I will start with maybe a equal to 0 and b equal to 0. Then what would be the value of y? I would check. So if a equal to 0, b equal to 0, obviously y will be 0. And then since what is the output here? First data point, if I check, it is 5. It is really less that we are predicting. So I would increase one or the other one. So let us increase a by 2, let's say. And then b, I have kept it as same. So a equal to 2, that is 2 into 1, 2, plus b into b is 0. So 2. Then my prediction would be 2. So now we are better. Instead of 5, we are predicting 2. Now I will increase. Already I had increased A by 2. So I will increase B also to 1, let's say now. Now A is 2. So 2 into 1, 2, plus 2 into 1, 2, 4. So we have improved a lot now. So now, since I had increased it to 2 already, now maybe I will increase B by one more point. A equal to 2, B equal to 2. So 2 into 1, 2, 2 into 2, 4. 4 plus 2, 6. Now we have exceeded basically. So now I need to decrease one or the other. So here I had already increased recently, and this one maybe I would reduce now. Now you will reach it there. So this is basically trial and error. I am not saying that this is the only, like you will reach soon, very soon. But this is how we can write a program that can learn. You start with some random values for a comma 0, and then predict the output. If it is really huge difference is there, or I can say that if it is more than the output or the original, then you reduce some values. If it is less, then you increase those coefficients. That is what it is. So this a comma b, these values that we are experimenting with, those are called as coefficients basically. So this is a kind of like this will be there throughout the machine learning. You start with some random values for these coefficients and then optimize them. That is what is called training is. This process of this adjusting values for output prediction that we are doing, right? This is what is training is. Ultimately, after some time, it will come up with this optimal values for A and B. So those are the weights and biases that you might have heard recently, like the parameters of the model. This is model, and these values, this coefficient that you are coming up with, those are called parameters of the model. And the process of identifying those parameters, this iterative process, it is called training. So that is how model learns. I hope I give some brief idea how can we train a model.
Yeah, Nagesh.
Yeah. Now, any other questions you have? I had planned one more use case anyway. It is already too late. Let me complete the curriculum what we are going to cover. Then we'll see. Yeah, in the first we'll start with Python. We'll spend some time learning basics of Python. That will be the first phase, and then we will move to machine learning. And in machine learning also, this time I am planning a few algorithms we try to cover. At least building some intuition and uh, essential concepts, essential basics for moving on to different deep learning or next part. We'll cover that. And then in deep learning, it is much more easier compared to machine learning. Actually, we have some architectures or its variations of our different variations of those architectures. So that one, like artificial neural networks, convolutional neural networks, RNNs, we try to cover. Um, Again, these are the foundations basically. You will not be directly working on them as a generative AI engineer nowadays. Even if you join as like ML engineer also in any company, I don't see a lot of companies working on machine learning or training deep learning models nowadays. So it is very, very what to say, very few companies, they are working in these two. Otherwise, majority of the job descriptions are the openings that I see nowadays. They are on the generative AI space. So we'll try to cover as much as possible these fundamentals of machine learning and deep learning in this part, and then we will move on to generative AI foundations and prompt engineering and what else, like building generative AI applications basically. So as part of Gen AI foundations, we will cover what are the LLMs and how do we control the output from the LLMs. How do we connect to the LLMs using different frameworks, or maybe you can use their own SDKs also. That is also okay. But using LangChain, it is much more convenient. So LangChain we'll discuss, and how do we uh, build applications using LangChain, and in the agent space, the most used or most sought framework is LangGraph. So that we will discuss in the next step. But for generative AI applications, I'll try to cover LangChain now. For this batch, more focus would be on the applications building side rather than anything else. So uh, yeah, as part of GenAI Foundations, we'll try to cover what are LLMs, how do we control the output from the LLMs, how do we connect to different LLMs, and using LangChain, how do we build the application. These are different topics that we will be covering. Structured output and pattern, this thing, it comes under the LangChain itself, actually. It is part of LangChain. And then we will move on to this is one of the important topic, actually, RAG and knowledge systems. This is something that almost you can expect questions around this in every interview, whatever it may be. And even the companies also, actually, there is a real work going on with respect to RAG. Every company that you see, uh, they are building one or the other application in RAG, because it is very important. Why RAG is so important is LLMs have these large language models. They are the ChatGPT kind of, like they are the technology behind the ChatGPT or Gemini kind of applications, right? So they are the models behind these two applications. So they have two main disadvantages. First one is, it is their input capacity, that is the amount of input that you can pass to them. It is not unlimited. There is a limitation to it. In the earlier days of ChatGPT release that you might have seen, if you copy paste lots of text and ask some question about it, it refused to answer that. It was not the same scenario like what we have right now. So that input sequence length that you are giving, input uh, capacity of these LLMs, it is limited. It is not unlimited. That is first thing. Second thing is, there is the parameters of that model. Those weights and biases, or I can say that the knowledge of that LLM that you are using through those applications, it is frozen in time. Frozen in time means it has been trained on the data till a cutoff date, actually. Maybe they might have trained it whatever the information that is available till last month, or maybe whatever may be that cutoff date. They decide until that point, whatever maybe the information that is available, they might have trained it on. So it doesn't know about your own internal policies. It doesn't know about let's say, like, what are the onboarding, what is the onboarding procedure at so and so company, what is the leave policy at so and so company. So these kind of things, these LLMs, they don't understand, or they don't know, basically, because they are not trained on it. And the recent happenings, like what is the status of US Iran war, this kind of questions, if you ask, current affairs, basically. So it will not be able to answer, because it has some cutoff. Before that, whatever it was there, it is trained upon that. So because of these reasons, but what is the usage? Like, these are the main expected questions from the user, and expected response from the LLM, right? So what is the, like, use of not having these capabilities? For that, this ChatGPT nowadays, they have implemented, like, they are attached with the web search tool, basically. Whenever you ask something about the current affairs, or maybe recent happenings, basically, then it searches the web and then fetches it and interprets you back to you in the like proper language, like how whatever it is. So it is the interpretation that it is doing, or rephrasing that it is doing. It is not generating there. It is searching the web, fetching that content from the web, and interpreting back to the user in normal language. That is what it is doing. It is not generating. But if you ask something like what is Newton's third law, then it wouldn't search. It fetches it from its knowledge. It fetches it from its own parameters. It doesn't search. So that is the difference. Anyway, we'll see that. So why companies are building RAG is because these are the two main limitations. Everybody cannot use ChatGPT in their company, right? So it is kind of like training these LLMs are, I would say, rather than training, creating that, uh, making sure that these LLMs have the information about their own data about which we are expecting the responses from these LLMs. That is where RAG fits into, RAG comes into picture actually. So that you can see a lot of like use cases for this. RAG full form is retrieval augmented generation. So what you do is you have your own proprietary data. You retrieve the uh, relevant text from for the user query, augment it with the prompt, and generate the response. That is what it does. We'll discuss that in detail. I had planned use case, but unfortunately, yeah, it's late. So this is very important. We'll focus that and we'll build one application on that. And then next one is AI agents. Obviously, this is the most sought again. Uh, it is AI agent is nothing but LLM with some extra or additional capabilities. That's all. So LLM, when it comes to LLMs have this mainly these capabilities. One is we call it as NLU, natural language understanding. That is language understanding, and NLG, language generation. So both of them put together, we call it as complete language intelligence. Okay, so LLMs basically they have this language intelligence. That's all. Apart from that, they cannot do anything. So in case if you want this LLMs, if you want to build an application where it is something like what we call ticket booking system. You take the input from the user and identify which movie ticket and what is the price limit that the user has kept, and then you go and book the ticket. These are the things that you are expecting from LLM. It cannot do. It can just maximum it can do is looking at the data. It can maybe suggest, okay, during this timing so and so movie is um, available, something like that. So and so movie is screening in so and so screen, something like that. That's all maximum it can do, but it cannot go and book. For that we need agents actually. So LLM with some capabilities are tools. Tools are nothing but capabilities like, as I mentioned, web search tool, weather tool, calculator, these kind of things. It is called agent. This agent can perform actions. So it is something like LLM with some limbs attached to it, like it is with the hands, legs kind of thing. Now it can take action. That is the difference. So how do we build the agents? How do we that we will discuss again, repeating LangChain and LangGraph. These are very, very important frameworks when it comes to this agentic space, basically generative AI and agentic space. So we'll cover that. And then like this is one part of it. How do we build single agent, and then how do we build multiple agents? That is multi-agent orchestration. That also we'll be able to do with LangGraph. And for everything, whenever we are building RAG use case, or it could be agent use case, we will cover how do we test it also using different frameworks. Like for RAG, the famous framework is RAGAS basically. And when it comes to any other, like it all depends on the use case. One more issue with testing or learning testing of this AI is um, it involves a lot of technicalities actually. It is not simple something like in traditional software testing. It used to be more of like you need to understand the application, you need to think of edge cases, these kind of things, and then you will be able to prepare the test cases and test it. But here it is something like you need to understand same thing. You need to understand the purpose, but ultimately how you are going to test it using those frameworks. Also, it needs bit of technical understanding. So we'll cover that as part of the application building itself, as part of like maybe debugging or guardrails. Not this one. We'll cover this as part of application building itself. And one more is each component of this AI application needs a separate evaluation actually, not complete like system level evaluation. So that is why that is a bit of tricky. So that evaluations you can see here I had included. We'll cover that for each and every system separately, not as a separate topic or something. So that is one. And finally, we'll try to do some use cases as well. Those use cases I have planned it, I have kept it separately. Maybe I can show it next. But as of now, that is what it is. Like we'll try to cover uh, starting from Python basics. We'll try to cover machine learning, deep learning fundamentals, and then move on to generative AI. In generative AI, we'll cover how to control the output from the LLM, LangChain, building applications with LangChain. Then we move on to LangGraph, build the agents, multi-agents, and then we will work on the use cases are there. So this is what is planned for. So these are the few of the tech stack that we will cover as part of this. So LangChain, LangGraph, QA. This is kind of like I would say a very role-based AI agent builder. I'll try to cover that as well. And then these are different what to say pinecone quadrant or vector DB, chroma DB is another vector DB. These are a few of the tech stack that it is not exhaustive list, few of them just for to showcase, to give you some idea. And this, of course, like once you were able to do this, you I can say in India, the generic role that I can say it is AI engineer. So any questions you have? Please reach out on this number in case if you have any questions about the course or anything. Uh, you can have this number. Please save it. And meanwhile, like before concluding, if you have any questions right now.
And the class timings will be same, right? Like every day.
Yes, it is. Yeah, it is 8 to 9 every day.
Mhm.
Yeah.
And it will be continuing from tomorrow, or it may.
It is not tomorrow. It is starting from Wednesday, if I am sure.
Wednesday. Okay.
Yeah.
And link will be same, or it will be giving different link for that.
I actually the link will be same for all the sessions, and
Okay.
we need like tomorrow we have some work, so we'll start from Wednesday onwards, and it will be like from Monday to Friday, and we'll plan some for workshops also in between that program after each section or for each important topics like that.
Okay.
Okay.
If in case we miss any session, so the recorded video, how we'll get that recorded video?
Actually, we have the LMS platform, like where you can access the assignments and every recorded sessions and every notes of each session. And what we had discussed today, we'll upload it out by 11:30 max after each session.
Okay.
Okay,
Yeah.
and that will be valid like for up to minimum 6 months to 1 year.
Okay.
And it will be the restricted one, and you should not share the credentials with some other people also. And if you
Mhm.
access that thing with different systems, it won't work, it will block.
Which means same system will
Yeah,
access.
you have to use the logins in the same system, otherwise like you have to log out from the system and you have to log in from another system.
Okay.
Okay.
Mm.
Yeah.
Yeah, we're good then. Thank you.
Any other questions anybody has? Okay then. If no questions, Praveen, can we conclude?
Yes, sure. Actually, anyone has any doubt regarding this? Like from Wednesday, we're planning the sessions. So you can use the same link like, throughout the course stream. A part of this, anyone have the questions regarding any topics wise or anything like what we're covering?
No questions.
Yeah, yeah.
Yeah, no problem. Then we will conclude, right?
Yes, yes.
Yeah.
Yeah.
Thank you.
Thank you, Mr. for your time. Thank you. Thank you, guys.
Thank
We'll see
you.
you on Wednesday then.
Okay.
Yeah. Bye. Have a nice day.